So class about annotation, and I told you a little bit earlier what is annotation. We are the information on top of information, but some definition that I quoted in for my PhD, I was sequencing the strawberry genome and annotating the strawberry genome. I loved the annotation because it was like you sit down a long time in front of the computer, you run this analysis, and you have information that you can put in your dissertation. It's great. It's not like it failed. Everything you find is information, and I loved it. So, okay, the formatting got a little strange here, zoomed in too much. But you take raw DNA sequence, and you're like, what do you mean by raw? It means you had the reads. Remember the DNA reads, which are small chunks of DNA sequence, and they can be as small as, I think these days, 50 base pairs. That's the smallest I heard of. Or as long as the longest I ever heard of is like 1700 base pairs. And then you took those reads and you assembled them into contigs, remember? And then you take the contigs and you assemble them into something I didn't tell you, but they call the scaffolding. And then you assemble that into the genome. So it's putting the puzzle together. But the raw DNA sequence means you have these reads already assembled, okay? So there was already some work done. And now you have this book, which may have some chunks put in the wrong spot, but still you have it assembled. And what we do is we add the layer of analysis to see, okay, what do those letters do? And we're trying to find biological significance and to see, okay, I have the DNA sequence, so what? There's actually a lot of criticism when the United States was sequencing the human genome, because they're like, if you're gonna get the letters but not know what they do, what use is that? But now we know that it was really useful, thank goodness. So here's an exercise for you. And I just took some DNA sequence from NCBI. I think I was looking to get a DNA sequence from like a chromosome, and I was like, I'm gonna use a small chromosome. So the Y chromosome is pretty small, but this is not the whole thing, right? And I'm just trying to tell you here that, like, look, I didn't put everything because it won't fit on this page, but I'm just saying, okay, somebody sequenced the Y chromosome, and then when we assembled, this is some chunk of the sequence. Now I'm going to let you guys stare at this, and you can chat with each other or with me. You know what? I'm gonna make breakout rooms so you can talk with each other, hopefully. And I want you to see, do you know what the sequences in green are, the ones in red, what's in yellow and blue, and then what's the rest that is just in black lines?